This is on the Studio 7576 tangent, cosine, sine. Honestly, don't know why they're doing cosine and sine first before the tangent, but okay. Uh, when I think of trigonometric ratios, which is sines and cosines uh, and tangents, I think of the phrase SOHCAHTOA. So no, SOHCAHTOA. Okay. SOHCAHTOA, and it's broken up into three stages: the So, the Ka, and the Toa. Um, right now we're going to talk about the Toa part. And the Toa means the tangent, T for tangent. We call it short term is tan, is equal to, O is for opposite, over adjacent. Opposite over adjacent. And when we talk about opposite over adjacent, we're talking about opposite of a particular angle. These all apply to right triangles only. Right triangles only. We'll talk about the So and the Ka in the next section. Today, this right now is just focusing on the tangent. Opposite over adjacent, and like I said, opposite over adjacent of a particular angle from that triangle. We'll talk about what that means in a second. Again, they talk about trigonometric ratio as the ratio of the lengths of the two sides of a triangle. Um, Remember, in a right triangle, we have the legs, which are the sides that are not opposite of the 90-degree angle, and then the side opposite of the 90-degree angle is the hypotenuse. Okay. Um, right, so here's what they talk about in terms of tangent. If we're just talking about A, here's angle A. Actually, I write it outside. Here's A. Here's B. And here's C. When we talk about tangent, again, tangent is the geometric ratio of the legs or the hypotenuse, any side of the right triangle. When we talk about tangent, it's going to be tangent of an angle, in this case, angle A. It's going to be the side opposite of A. So in this case, we would say BC. Right, the side opposite of A, which is BC, over adjacent. And adjacent is the side that's going to touch A. that's not the hypotenuse. So if it's going to touch A, one of the legs that touches A that's not opposite, that's going to be here, down here in AC. So adjacent, which is AC. All right, opposite over adjacent. There's two sides that touches angle A. That's the hypotenuse and the leg. We don't use the hypotenuse with tangent, just the adjacent side. So when we talk about adjacent, we always talk about the side that's not the hypotenuse. Not the hypotenuse. We also have tangent of B. And that's, like I said, opposite over adjacent. Opposite of B is AC. And tangent of B is BC. We do not use the hypotenuse in tangent. Right. So when we do an example, here they want us to find the tangent of J and K rounded to the 4 decimal places. So if we do tangent of J, that's going to equal, again, opposite over adjacent. Opposite of J is 24. Adjacent to J, that's not the hypotenuse, is 32. We can simplify that dividing by 4, right? That's what 6 over 8. Which is 3/4. Alright, so then that means that it says round to the 4 decimal places, so that is 0.75. And then tangent of K, same thing, opposite over adjacent. Here's K. Opposite of K is 32. Adjacent is 24. So that's 4/3. And 4/3 is 1.33333, 4 decimal places. If you want, you could put 0, 0 here. For 2, they asked for tangent of J and K as well. Tangent of J, again, opposite, adjacent. In this case, it's 8 over 17, no, 8 over 15. And 8 divided by 15 is 0.5333, 4 decimal places. Tangent of K, opposite of K is 15. Tangent of K is 8. It's 15 over 8, which is 1.875. If we do 4 decimal places, 0. And we can use tangent to find lengths of sides of the legs as opposed to just the angle. or the ratio. So here they want us to find x. We can use tangent. We would say tangent of 61 is equal to, or opposite over adjacent, so it would be 22 over x. Multiply both sides by x, divide by tangent of 61, and we get that x is equal to 22 over tangent of 61. And you get 12.19. Same thing here to find x. We do tangent of 56, which is x over 13. So multiply both sides by 13. So tangent of 56 times 13, and that should equal your x. So x equals 19.27. One thing I forgot to mention, when you do these things on your calculators and you make your calculations, you have to make sure that your calculators are set to degrees. There's degrees, radians, and gradients. So in your scientific calculator or graphing calculator, degrees is set up as DEG. Radians set up as RAD. And then gradients is set up as GRAD. Make sure that your scientific calculators are set up in degrees. Otherwise, you're going to get different answers, and it's not going to be good. Oh, no, it doesn't say GRAD. I'm sorry, it says GRD. So this is for degrees. This is for radians. And you guys will do that when you take pre-calculus, calculus. And this is for gradients. We don't really use gradients much. But make sure it's set to degrees. Bing, 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 the one on top. Otherwise, you will get false answers. Don't let that be you. All right. So when you have a 30, 60, 90 or 45, 45, 90, you can have scenarios which are always the same. So if I have a 30, 60, 90, suppose the length of the shortest leg is 5. So it's the 30, 60, 90. We already know that this is going to be the short leg. In this case, they say the short leg is 5. So that means that the long leg is 5 root 3. And that's going to be 2 times 5, so this is 10. All right, they want to show when you have tangents and of these guys, they're going to give you the same answer every time. So if I did tangent of 60, again, opposite over adjacent, so it'll be 5 root 3 over 5. That cancels, so I'm going to get square root of 3. Tangent of 60 is always square root of 3. If I was to do tangent of 30, it's going to be 5 over 5 root 3. These guys are going to cancel. That gives me 1 over root 3. And we don't like 1 over root 3, so we multiply top and bottom by square root of 3. And we would get root 3 over 3. Okay. This also works with 45, 45, 90. So if I had a 45, 45, 90, right? So let's say this is 1, this is 1, this is square root of 2. If I was to do tangent of 45, it would be 1 over 1, which is 1. No matter which side it is. And if this was 6 and 6 and 6 root 2, I would still get the same thing. Tangent of 45 would be 6 over 6, which is 1. Alright, so that's 7, 5. Alright, so 7, 6.